What's up? Ooh, my voice. What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. And good morning if you're in LA or California for that matter. It's 8:42 a.m. Woke up about an hour ago, but still kind of waking up, if that makes sense. If you're in other parts of the world, it is late after this afternoon on the East Coast, and other parts it's probably later in the day or even evening. So what's up to everybody? And thank you guys so much for joining. It's a big day. Today's a very important day because it's the day before the SAT. Everybody's taking it tomorrow, whether you're taking international or U.S. Vedant is here. He says, any tips? Yeah, that's what this is all about. So we're going to do a few things this morning. We're going to make it a little bit of a longer stream than the last few days. We're doing just like a mini test. So here's the plan. And you guys, look, by the way, somebody's saying, hey, I'm nervous for tomorrow. That is not a bad thing. You want to be nervous to some degree because it means you care. Now, hopefully the preparation will take over. If you've done that right preparation, those nerves are not going to be a big deal, and your instincts will kind of guide you. Make sure you review, check your stuff, all that when you're going through the test. But you're going to be fine, believe it or not, despite the fact that your body might be like, oh my God, I'm gonna fail. That's totally how it goes. What's up, Kyle? What's up? Hey, Nepal, amazing. I'm from India. Jang, what's up? Welcome. Journal with Lily, what's up? Welcome. So anyways, what we're going to do today is we're going to start with, again, one of these mini tests. I've been doing a lot of these recently. This is like the 44th one or something. We're going to start with that, but then I also want to go over the important formulas that you got to know. Plus, at the end, I want to talk about two important trends that I've been seeing lately on the recent SATs, especially 2021, 2022. Actually, there's three trends. You know what? Maybe let me start with those, okay? Because I keep seeing these types of problems more recently, so I want to give you a heads up that I strongly believe that one of these or two of these or something like that are going to show up. Okay. So there's a couple things, and I'm gonna load up let me go to YouTube here real quick and also show you the video or the stuff I'm talking about. So if we go to my critical concept videos, where they're like, I think it's in this one. Okay, so check it out. Something that's been popping up a ton lately is, let me show you here. Where the triangle stuff. They have these triangle congruence and triangle similarity questions, and I don't know if you guys have noticed this in the recent tests or anybody who's taken them recently. What they're doing is they're saying which ones are necessary to prove that these two triangles are congruent. They're not asking you to actually like come up with the names of the theorems, right? So there's side, angle, side. There's these ones. But they're asking you essentially indirectly how to apply the theorem. So they'll say, like, let's say they give you just a angle and a side that are congruent. They say which one of the following is sufficient to prove that these two triangles are congruent. So it comes back to these congruence theorems. You gotta know these theorems. I guarantee, this one I can guarantee there's gonna be one question on the SAT. So this is more recently. So which one is sufficient to prove? So notice this is the only 5 ways you can prove triangle congruency. And when we talk about angle, side, angle, or specifically actually side, angle, side, when we talk about this, it's very important to notice that and you can watch this video again just to because I explain it more thoroughly as well, but it's got to be side, angle, side, meaning that angle's got to be sandwiched in between those two congruent sides. Otherwise, it's not side, angle, side. For example, here, I'll quickly annotate. Let's see if I can get this to work here. It's going to make me reload. Okay, 1 second. Let's reload this.
To right triangle.
Let me back it up here. So, for example, did it come? Here we go. For example, if I have a triangle like this and a triangle like this, and if I have side, side, right? You see side, side, and then angle. That is not side, angle, side, or angle, side, angle. This is not proving these two triangles are congruent. It has to be inside, side, angle, side, in that order, okay? We do have, and I've seen them test angle, angle, side a lot. So angle, angle, side, if you have any two angles and then just another side, you're good to go. It's enough to prove congruence. Okay, they've also been doing these with similar triangles, so that means you got to know your similarity theorem. So angle is the most commonly tested. You show two angles are congruent in two triangles, they're similar. That's it, meaning they're proportionate. If you show one angle, but then two sides around it are not congruent but proportionate, that's what this is saying. Meaning, like, let's say this is 2, this is 3. Oh, wait, let's do it better, more accurate. Let's say this is 5 and this is 10, and this is 2 and this is 4. So you're showing a 1 to 2 relationship, and then the angles on the other side are congruent. So this is also enough to show similarity. And likewise, excuse me, if you can show that all three sides are proportionate, so let's say we do, 5 to 10, 5 to 10. I'm just making this an isosceles triangle, and then 2 to 4, 1, 2, 1, 2, 1, 2. You can so show that they're similar. So this is one of the trends, okay? The other trend, so there's two other trends. One is that I've been seeing them for whatever reason asking a lot about triangular prisms. I don't know why. Triangular prism is this, and particularly volume, and it just seems to keep coming up, so I want to give you guys a heads up. A triangular prism looks like this, but all prisms are the same, because to calculate the volume, what you do is you calculate the area of the face. And what I say is the face, it's not the bottom, or sorry, the base. It's not in the bottom. It's the shape that is kind of repeated or extended back. So what you do is you calculate the area of the base, and then you multiply it by the height. And the height, again, is not going up necessarily, but it's this length that is extending this base, that shape. That's how you calculate area of volume of a prism. Also, you could do a rectangular prism. It's pretty much the same thing. Calculate the area of this and then multiply it by the height, by how much it's extended back. The last one that they are testing on, let me do a blank screen here. Okay, so the last thing that they seem to be testing on are like especially graphs of like different functions, exponentials, but I've also seen like some of these guys, right? Like 1 over x minus 4. So here's the deal. It doesn't matter. It's not like you have to go out and memorize what these functions are, the baseline functions, or like, oh, I have to know this. And no, you don't. It's okay. What you need to be aware of is that you can plug in points, all right, and sort of decipher and figure out which graph matches with whatever function they're testing. Now, as an aside, just to know, when you do see something like this, there is going to be a vertical asymptote where the denominator zeroes out. For example, here, there would be a vertical asymptote at x equals 4. Again, asymptote is invisible, so it's just like an invisible line that will not be crossed. And then on either side, let's say if this is 4, right? On either side, you're going to see the function, and you'll see it'll never cross that line. If you remember that, great. But if you don't, that's okay too, because you can just plug in other points around here and be like, oh yeah, does that match what I should be getting in this function? If I plug in 5, right, here would be 5, do I get 1? Because 1 over 5 minus 4 is 1. If I plug in, let's say 3.5, 4.5, do I get 2? And it should match up, so on and so forth. So these are the really good strategies that you want to use. So don't get thrown off if you see one of these crazy functions, like, I don't remember what this looks like. Okay. So those are some of the, this video is probably going to be like, I don't know, another 20 minutes, 30 minutes, something like that. Okay, so that is the gist of these trends that I've been seeing. So now we're going to jump in. I want to do a mini test real quick. This will take 15 minutes, probably less. And then we're going to jump in at the end to the formulas. So we've got formulas coming up, and I'm trying to think, actually, should I show you guys the formulas now? I don't know if you guys have a feeling like, hey, I'd rather see the formulas now, and then the questions later, you tell me, and we can kind of play it like that. But, Ashley's taking out his birthday. That's kind of cool. It's kind of a bummer, too. I guess it depends how you look at it. Anyways, okay. Well, here, angle, side congruent. Yeah, that is a congruence theorem. Angle, side, somebody asked, how is that congruent? If you think about it, look, check it's making me reload this page. Hold on. Sure, let's reload it. People want the formulas. Okay, we'll do the formulas first. Sorry, glad I asked. If you're wondering how is angle, side a thing, right? Well, angle, and then we got a side. So you're like, why? Well, remember, Angle, angle means that the third angle has to be congruent as well. Because think about it. If let's say this is like 30 and this is 70, that's 100. 30 and 70, that's 100. The last side has to be 80 because it has to add up to 180. So that means angle, angle, side is really the same as angle, side, angle. You see? So it has to be true. All right, let's get in the formulas. Here we go. All right, so these are my 23 formulas that are super, super important. So let's talk about all of them. Yeah, you're welcome for the review, Arjun. No worries. Okay. Slope of a line. Gotta know it. Hopefully you do know it. But if you don't, you take the difference of the y's, rise, over the difference of the x's, run, and that equals the slope. So here's an example, right? And it doesn't matter the order. That's the beauty of it. People are like, hey, it's y2 minus y1 or y1 minus y2. It doesn't matter as long as you're consistent. If you do y1 minus y2, it's got to be x1 minus x2. So the order of the coordinates has to be the same. If it's not, then there's a problem, right? You can't mix that up. So in this example, we got 7, 2, 5, 1, and I got 2 minus 1, top minus bottom, top minus bottom. That's what I've done. Now, if I were to flip it, 1 minus 2 over 5 minus 7, it would be negative 1 over negative 2. That's still positive 1/2. You see? So it doesn't matter. Slope of a line. Number 2, slope-intercept form. Essential, and it's really cool because when you're in this format, you can quickly identify what the slope is of the line, this number in front of the x, and what the y-intercept is. You don't know the slope if it's not in this format. I mean, maybe you can kind of figure it out, but don't just look at the number in front of the x and be like, hey, that's the slope. It's got to be in this format, then it's the slope, okay? Point slope. This is debatable in a sense. Like you could probably make your way through the test without it, but I wouldn't recommend it, and that's why I think it's really important. I put it on the list. I think this is a great formula. You can come up with the equation of a line if you know a single point, 4 and 3, right, and the slope, 3/2. And then you can still put this into slope-intercept form by distributing and then adding the 4 and all that. But it's super cool. Look, if you see the graph of this line, you can see it's a slope of up 3 over 2. And that coordinate 3, 4 is right there. So this is a pretty important formula. No, do not grind the whole night, Mihir. I would say sleep. Sleep is going to be more important. I mean, the only way I would say grind is if you've done like barely any work and you're like forgetting everything or don't remember a lot of the math stuff. I mean, then it's a little different. But I would say sleep, 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 sleep. That's super important. Okay, midpoint formula. So the midpoint formula is going to help you find the midpoint between 2 points. It's pretty cool. So it's pretty basic, to be honest, in the sense that like you could kind of figure it out logically. But what you're doing is you're taking the average of the x values, 8 and 6, right? That's the average. So that's how you're getting, what would that be, 7. And then you're taking the average of the x values, of the y values, 4 and 7, which would be 11, 5.5. I didn't even write that here, but the midpoint would be, let's see if this works. It makes me refresh. Yeah, it makes me reload. Why not? Let's do it so I can write a little bit. In this case, like I didn't write it, but the midpoint would be 7, 5.5, right? So that's how you do the midpoint formula. It's pretty cool. This will also come in handy sometimes if they give you 2 outside coordinates of a diameter of a circle. You want to find the middle. So, somebody's saying, what is it? Can you review circle arc problems? Ratio major, interjectors. Wait, hold on. Circle arc. Yeah, these might come up when I do the mini test. So we'll come back to that. Okay. This is the distance formula. The distance formula is how you get the distance between 2 coordinates. So this is also helpful on circle problems when you're trying to find like the length of the radius or something like that, right? So we've got the distance. Check it out. We take the difference of the x values, 5 minus 1 squared, plus 3 minus 0, right? I'm taking the y's, 3 minus 0 squared. And just to show you a little bit more, if I can explain. So that becomes 4, so you can see what happens. 4 squared plus 3 squared, right? That becomes, squared. And that becomes 16 plus 9, which is 25. And the square root of 25, that's how we get a distance of 5. It doesn't show all the work. But it's a really important formula. You can also, if you want, plot these points. If you're like, I can't remember the formula. So you'd be like, here's 1, 0, and then here's 5, 3. And you're like, okay, I've gone across 4, and I've gone up 3. Guess what? It's a right triangle. So that's what the distance formula is. It's Pythagorean's theorem. 3 squared plus 4 squared is 5 squared, and that's how you get that distance. But, if you have the formula down, you're good to go. All right, some people were talking about arc. Yeah, Khan Academy level 4 and level 3 are really tough, tougher than the SAT. So don't get freaked out when you see those problems. This is a very important formula. You got to know this. Length of an arc. But guess what? It's not that complicated. It's your circumference formula, which you know, which is even on the SAT. You know your circumference, and then you're taking this fraction of it, which is the central angle over 360. Why 360? Because that's all the degrees in a circle. So it's part over whole. That's it. If they give it to you in radians, it's this over 2 pi. But it's the same thing. Or you can convert the radians to degrees. So you take this fraction of the entire circumference. Likewise, area of a sector. What are we talking about? We're going back to the area formula, pi r squared. And then we take this fraction, central angle, out of the total 360. But you see it's the same principle. Fraction of the total area, fraction of the total circumference, right? Somebody asked volume of prism. So I did talk about that earlier in the video. So if you want to rewind or watch this later, maybe you can't rewind now because it's live. No, you should be able to. But yeah, I did talk about that already. And let's go to the quadratic formula. I mean, what can I say? It's like the most famous formula in algebra, right? So you got to know this one. It's negative b plus or minus. I got a song for it, right? I don't know if you guys seen it, so play it, whatever. It's if you're struggling to learn this, this is what I would recommend doing right now. Where is it? It's my music videos. And yes, I know they're cringy. People tell me that all the time, but they work. I swear. Okay. Hold on. Let's go to the chorus. You don't want to hear the whole thing. Don't have a quadratic function, and I see my child. Need to be plus or minus the square root of a squared minus 4ac over 2a. Need to be plus or minus the square root of a squared minus 4ac over 2a. Somebody's like, the song. Yeah, this is 6 years ago. My God, almost exactly 6 years ago in August. That's crazy. But I love this song. It makes me happy, and it really works. It really works. Like, as much as people make fun of me about it, it's really good. So, anyways, why is somebody crying? Your feed and Journal with Lily. Yeah, you're very welcome. Yeah, I agree with you, Hishita. I think the level 4, a lot of times I don't do level 4 with my students. It's just too much. So yeah, the John Jung is more difficult. I don't really use John Jung anymore because I feel like they didn't adapt their resources when the SAT changed. But regardless, it's still harder. Okay. So do we have to know limits? No, you do not have to know limits. Anyways, quadratic formula, you know how to use it, right? You plug that in there. I mean, this is kind of self-explanatory, but you plug in these constants, and then you can get it's to solve the for the x-intercepts. All right, a very important formula. Then we got SOHCAHTOA. Got to know this because SOHCAHTOA is always tested on the SAT. But not in a very complicated way, right? Oh, you know what? There's a fourth trend I forgot to tell you. I have been seeing lately these. So normally I would say, and I still kind of stand by this. I don't think you need to know the unit circle because there's ways around it. But lately, I have been seeing more of like sine of 3 pi fourths, right? What is sine of 3 pi fourths? The reason why I say you don't need the unit circle is because you can figure this out if you just remember, you convert it to degrees. That's 135 degrees. So you're out here. And then you take your reference angle, you make a little, this is a 45, 45, 90, right triangle, right? And you could be like, sine is opposite over hypotenuse, okay? And in a 45, 45, 90, you have 1, 1, root 2. You kind of know the sides, right? It's 1, 1, and then that time it's x, x, x times the square root of 2. But you can then you can be like, so it's opposite over hypotenuse, 1 over square root of 2, which becomes square root of 2 over 2 when you rationalize the denominator. So there's ways around it. That being said, if you do know the unit circle or want to lean on it, you can remember that, 3 pi over 4 is this point, and sine is the y value, right? So the y value here is positive root 2 over 2. Why is this not being funny? Hold on. And the x5, if they ask for cosine, it'd be root 2 over 2 as well, but negative. So those are the different things. The other thing you do want to remember is the quadrants. Like, it's all students take calculus, right? Everything's positive here. Only sine is positive here. Tangent and cosine are negative. Only tangent and cotangent are positive here. Everything else is negative. You're not going to ask about cotangent. Don't worry about that. And only cosine is positive here. All right? So that's a nice little thing. But anyways, so SOHCAHTOA, sine is opposite, the blue, over the hypotenuse, green. That's right there. Cosine, ka, adjacent. And it's all relative to this angle. If I was doing this angle, adjacent would be the blue, and the green would still be hypotenuse. Hypotenuse is hypotenuse. And then you got tangent, opposite over adjacent. Opposite relative to A, opposite over adjacent. All right. Probability. All right, here we go. So probability is a relatively straightforward concept. It's the number of favorable outcomes over the total number of outcomes. So on a dice, you roll a dice. What's the probability of rolling a 1? It's 1 out of a total of 6 options, so 1/6, right? Okay. And joint probability, if they ask, hey, what's the probability of this and this happening? It's the first probability times the second probability. So what's the probability of rolling a 1 and then rolling the dice again and getting a 2? It's 1 out of 6 times 1 out of 6, 1 out of 36. So, all right, formula 11. Circle equation, gotta know it, gotta know it, gotta know it. No excuses. So it is x minus h squared plus y minus k squared equals r squared, and this tells you what the center is, right? It's the reverse, right? So it's minus 2 becomes positive 2, plus 5, negative 5, and this tells you the radius. This is the radius squared. So if it's 36, the radius is 6. Boom. The other thing to remember is sometimes there's circle problems they'll give it to you like this. They'll be like x squared plus 8x plus, I don't know, y squared minus 4y equals 7 or something. Well, wait, hold on. Let me see if I want to make the numbers good. 16. Let's say 5. Okay. Yeah. So you'll see it work out nice. So you got to remember, in this case, you have to complete the square before you can say anything. Like, you can't say, hey, the radius is square root of 5, because it's not in standard form. So you have to complete the square. You're like, what's half? So you take half of this and square it. So you add 16. You add 16 here too. Half of this and square it. So that's 2 squared is 4. But you add 4 here as well. And then now you get x squared plus 8x plus 16. It's a perfect trinomial. So now you can factor it, and it becomes x plus 4 squared. You can also factor this, and it's a perfect trinomial. That's what you're doing. You're making a perfect trinomial. Y minus 2 squared equals 5 plus 16 plus 4 is 25. Guess what? Now you know what the circle is. It's got a center at negative 4, positive 2, and it's got a radius of 5. Sorry, I hope you can read that. But that's the idea, that they'll make you do this, I'd say, 1 out of every 2 or 3 SATs. Most of the time it will be in this format, and it's pretty straightforward, but sometimes on the harder ones you'll have to do that. Yeah, b over 2 squared to add to both sides. Exactly right, Pancake. Good job. Exponential growth. Gotta know this as well. It's very important. There's always exponential problems. So whatever is out here that's not being, taken to an exponential power, that's your initial value. Important to know that. So if that was like, and there's some good examples here. This is the growth rate, but it's in, like, if it's a percent, you have to put it in decimal format. So 5% would be like 0.05, right? Here's growth, here's decay. And it's basically like, if you're growing, it's growing at 13% per year from the previous year, right? So you take that, it's growth, you add it to 1. So this would be 200 times 1.13, right, to the t power, okay? That would be your exponential of 13% growth rate. Here, when you minus it, you'd have 0.91 to the t power, and this would show you an initial value of 150. And so you see that the 0.91, when it's less than 1, it's decay, you're losing. And what you're losing is that 9%. And so this is very important. And also it's important, too, to recognize what is exponential growth. It's a growth rate. It's a percentage growth rate based on the previous year, not based on an initial value, because you could just say, hey, it's growing 20% from the first year. Well, that's a constant rate of growth. That's linear. So we want to be very specific, especially when you're differentiating between linear and exponential, okay? Simple interest, it's like, simple interest is, I would say, not I don't say you need to know it because it's a straightforward percentage calculation. So I don't put it as one of my essential formulas, and like I don't really see it that much. But if you're like, hey, I put $500 in and I get 10% interest, you just be like, take 10% of 500. So I would say not really. Okay, vertex of a parabola. Super, super, super important, especially when a quadratic is in this format. So for example, if you're like y equals 2x squared minus 5x plus 7, I don't know, I'm making it up. And you're like, what's the vertex? It's negative b, so it's that negative 5, which is 5, over 2 times 2, which is 4. So my vertex is at 5, 4. Again, that's the x value. And then if you want to find the y value, you plug this in. So I picked really bad numbers, but I guess I'll do it. This squared is 25 over 16. That's 50 over 16 minus 25 over 4 plus 7. Ugh, this is terrible. So that's 28 over... No, wait, hold on. I'm going to have to multiply by 16. 70, 42, 112 over 16 plus... and that's 100 over 16. 50 over 16. This is so bad. And then it's negative 50... 62 over 16, 31 over 8. So this is terrible. They won't do that to you on the SAT. The numbers won't be this bad. But that's how you can calculate the vertex of a parabola. Like, cut me some slack if I made a mental math error, but roughly, like, that's the process. All right? So that's how you find the vertex of a parabola. Super, super helpful. By the way, vertex of a parabola, if they give you the x-intercepts, a fun little trick is it's in between the x-intercepts. So if they ever say, hey, this is my... They give it to you in this format, 2x minus 7, x plus 3 or something. So you'd be like, oh, cool, my x-intercepts are at 7 and negative 3, right? And this is going up. Well, where's my vertex? It's right in the middle of 7 and negative 3, right? So you take the midpoint, or 7 and negative 3, and it's 2, right? 2 is 5 away from each. So you know the vertex is at 2, comma something, I don't know, but then you can plug it in, right? 2 times 2 minus 7, negative 5, negative 10 times 5 is negative 50. So 2, negative 50. So you see how you can find the vertex that way as well. Little fun trick. Compound interest. Yeah, I mean, that comes in from the, what's it called? What I just went over. Exponential growth is essentially compound interest. They're not doing it. I rarely see them say compounded monthly or something. So it's usually just annually compounded. Okay, vertex form of a parabola, very important. When you get a parabola in this format, right? Let's say 2 times x minus 7 squared plus 4. You can be like, oh, my vertex is at the opposite of that, 7, and then just that as 4. You see? So it's very important. If this was plus 7, then it'd be negative 7. But the y is just whatever it is, whatever it appears. Yes, you do have to know when sine, cosine, tangent are negative. I talked about that earlier in the video as well. Remember, all students take calculus. Everything is positive here. Sine is positive here. Tangent is positive here. Cosine is positive there. Okay? All right. Pythagorean theorem. Okay, no, they don't clear your calculator. At least they haven't. I haven't seen them do that at the last couple times I've taken it. But I'm not the one to, I don't know I never put programs on my calculator. I'm just saying. So I'm not sure what the rules are, but because I don't know, I don't do it. A squared plus B squared equals C squared, right? You probably know this formula. Very important. Gotta know it. And that's it. That's how you find the hypotenuse. That's how you find the legs. As long as you know 2 sides, you can find the third side. Most commonly, one is a 3, 4, 5, right? This fits that paradigm. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. That's it. And if you didn't have, right, the idea is use it to, when you don't know this side, right? So be like 3 squared plus 4 squared equals x squared. 9 plus 16 is 25 equals x squared. Oh, so the hypotenuse is 5, like that. Distance equals rate times time. I got another song for this. I won't play it though. But yeah, distance equals rate times time. Simple formula, you might be like, well, this is so obvious, but it actually really does come in handy for certain problems. So asymptotes, like I said, not really, but it might help if because they have been giving these like 1 over x minus 4 function graphs. So you'd be like, hey, the asymptote is where it zeroes out in the denominator at x equals 4. But it's not essential. So I'm not like saying you need to freak out about it, but it's a little nice thing if you have it. Okay, so let's go to 17. This is a fun little thing. They always test on this. So a lot of times they'll be like, hey, if sine of, I don't know, if sine of 40 equals whatever it is, like, I don't know, sine of 40 equals A, what is cosine of 50? Okay, like something like this. And it's also A. Bottom line is, if you have an angle and the complement of that angle, so sine of 40 equals cosine of the complement of 40, you know, when they add up to 90, aka cosine of 50. So this is basically one of the things that they always test on, right? So that's why I read out here, sine of 10 equals cosine of 80, sine of 20 equals cosine of 70. Likewise, if they give it more abstract, if there's like, here's angle A, angle B, and it's a right triangle, and they're like, sine of A equals, I don't know, they're like sine of A equals square root of 2. I'm just making this up. And then they might be like, what's cosine of B? Well, it's a right triangle, so this B is a complement of A. So sine of B, cosine of B is the same as sine of A, which is square root of 2. They love to test this. Okay, sum of solutions. This is a nice look. Again, if they give you a question, they say, what are the sum of the solutions of this quadratic? You're more than welcome to find the solutions of the quadratic, okay? I'm not saying you need this, but man, does it save some time, because if you get crazy numbers, like look at this one, right? They're like, what is the sum of the solutions? Well, I don't think, let's pretend I can't factor this. I don't even know if can I factor it? Let me just think. No, I don't think it's factorable. It'd be like, all right, quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. That's 4. Great. Then I have to do the whole thing. That's 20, that's 40. 49 minus 40 is 9 over 4. Then that's square root of 9 is 3. Maybe it was factorable. I don't know. 7 plus or minus 3 over 4. So then you get 10 over 4 as one of your solutions, and you get 4 over 4 as one of your solutions, right? So, oh wait, did I do that right? Oh my God. Oh, it's a negative 7 in the front. Sorry. My bad. So it's negative 10 over 4 and negative 4 over 4. Excuse me. So you're like, cool, and that's negative 5 over 2 and negative 1, and then you add them together, and it's negative 7 halves. That's the sum of the solutions. Or you can remember this and be like, oh, sum of the solutions, negative b over a, done. Right? Like, it's so much better. So anyways, that's the idea when we do these, right? So anyways, sum of solutions, great formula to remember. Okay, discriminant. This one's really nice because a lot of times they will, oh, give me 1 second. All right. Oh, okay, give me 1 second, guys. I got to go to my door. 1 second. Okay, sorry guys. Anyways, back to the discriminant. Apologize. So the discriminant is really important because a lot of times what they're going to ask is they're going to ask about, hey, when are we going to have no solutions, one solution, no real solutions, one real solution, or two real solutions? Now, again, you can go back and actually solve and be like, hey, this is the solution. I got two solutions. I got one solution, whatever. But this is a nice little shortcut. Especially sometimes you'll see these interesting problems where they'll be like, what's an example? They'll be like 2x squared plus bx minus 7. And they'll be like, for what value of b do we get one real solution? So you can straight up go into use the discriminant and be like, well, we need b squared minus 4, literally b, because I chose b, 4ac. We want this to equal 0, right? B squared minus 4ac, and then you can immediately solve for b. So what is this? Negative 8 times negative 7, 56. B plus 56 equals 0. So you'd be like, b equals negative 56. So this is a really nifty formula. And again, you see the breakdown here. This is one real solution, two real solution where it's positive, and then that's it. Just to remember, the discriminant is part of the quadratic formula, right? So negative b plus or minus square root of b squared minus 4, what am I doing? Plus or minus b squared minus 4ac all over 2a. And so if you're like, what's the discriminant? If you know the quadratic formula, you know it. It's under here. And this makes sense, right? When we say there's only one solution and this whole thing zeroes out, well, then this whole plus or minus thing, which is what gives you the two solutions, is now irrelevant. That's why you only have one solution in that case. Likewise, when this thing is negative, you're taking a square root of a negative. Guess what? Can't take square root of a negative, at least not for real numbers. That'd be an imaginary number, right? So when we take a square root of a negative, now our solutions are no longer real. That's why we say we have no real solutions. So a lot of this stuff, even if you don't commit it to memory, like you can kind of logically figure it out, okay? This one is a nice little one to have, but it's not essential because so don't kill yourself trying to memorize this, but it's nice if you know it. So if you want the area of an equilateral triangle, you square the side, multiply by square root of 3, divide by 4. But if you forget that, you just drop an altitude, okay? Make it a 30, 60, 90, and then you're like, hey, if this side is 10, okay, you know in a 30, 60, 90, the side opposite the 30 is half the hypotenuse. This is 5, and then the height is 5 rad 3, right? You remember your special right triangles. This is on the SAT. They give it to you in the formula sheet at the beginning. That's why I don't have it here. So this is how and then you can calculate the area. Base times height divided by 2. So that's it. Okay, let's go to Pythagorean triples. Again, these are wonderful to know, not essential, but very helpful. And the main one you should know is this one. This one gets tested over and over and over. And remember the multiples. So you'll see 3, 4, 5. So if you know 3 and 4, you know this is 5. Or if you see a 6 and an 8, you know it's a 10, 12, 16, 20, like this, right? So you basically take the 3, 4, 5 and just multiply it by common constant. Likewise, here we got 5, 12, 13. Less, but it will show up. I've seen the 8, 15, 17. I threw this on there because this is a common one, but I can't even remember the last time I've seen it on the SAT. So this is the one to focus on, I would say. Slope, when we're talking about finding perpendicular slope, like parallel slope means the slope is the same. So I didn't put it on here. You need to know that. Maybe I should have put it on here in retrospect, but I assume that's a little bit more straightforward. Perpendicular slope, however, not as intuitive, but it's the negative reciprocal, right? So we have, if this slope is 2/3, perpendicular line would be negative 3/2. We flip it and negate it, all right? Last one, formula 23. Last one is this one. We have n minus 2 times 180 to get the angles of any polygon. So let's say, you know a triangle's 180. Right, we got to know that. But if you didn't, you take the number of sides of a triangle, 3 minus 2 times 180, 180. Quadrilateral, 4 minus 2 times 180, 360. And a pentagon, here's just an example. But if you have a decagon, right, 10 sides, what do they add up to? 10 minus 2 times 180 is 800, 640, 1440, right? So that's what all the angles in a decagon. So this is just a nice little formula just in case it pops up. Okay. All right. Journaling with Lily, having anxiety. Again, anxiety, it's pretty cool, actually. I don't know if you guys know who Ryan Reynolds is, or there's a journalist that I'm a big fan of named Ariel Helwani. He talks about mixed martial arts all the time. I think he's the best of the best. He's amazing. And they both have a lot of anxiety. Everybody has anxiety, just to varying degrees. What they say is anxiety is their engine. They use the anxiety, their stress, different things to push them to get stuff done, to be productive. So don't necessarily shy away from the anxiety. Try and use it, try and harness it. As you get older too, you kind of get more adept at how to handle it, process it, etc. So that's it. We're going to do a quick mini test and then I'm going to dip. I'll call it a day. All right, here we go, ladies and gentlemen. So you're going to see me put some of this stuff into action. We're going to start, let me get a calculator, loaded up here. and then I'll come back and answer questions. And no, I don't have an English course, sorry. But we do have a math course. We have the best math course in the game. If you check our description link below, it's only $15 a month. You could literally sign up today, cancel today, and you'll get access to 4 practice tests and 4 video explanations per question. I mean, like, there's nothing else as good, I think, and as thorough, because I'm also explaining it very carefully. Plus, we got a bunch of other resources in there, so I would check that out if you want it. You want some last-minute material to review. Okay. Here we go. 3, 2, 1. Let's do it. Let's zoom in a little. All right. A team of meteorologists tracking the speed in kilometers, radius, maximum distance, cyclone center, wind speed. According to the plot, what is the radius of the maximum wind speed in kilometers? So radius of the maximum wind speed would be 30. So this is just kind of reading a graph. Boom. Done. The chef has 36 pounds of strip loin steak. The amount of weight loss from the trim on each pound is 35%. 75% more of the steak's weight is lost after cooking. So you lose. So first you've got 36, and then you're losing 35%, which means you're retaining 65%, and then you're losing 75% when you cook it. I wonder if that's true. I don't think it is. Maybe. So then you're retaining 25%. You see how I do that? So we got 0.25 times 0.65 times 36. 0.25 times 0.65 times 36, which is 5.85 left to serve. Boom, done. Okay, a shipping company charges $3.46 for the first pound and $1.53 for each additional pound. So that's -1 because that's after that. And he wants to spend under 100. So there's our inequality. So it's 3.46 plus 1.53 times P minus 1. It's B right there. We got it. Boom. 4. Jing is making homemade peanut butter. The equation above shows the amount of peanut butter B in cups for A cups of peanuts. What percentage of the volume of peanuts is lost when processing them into, wait, what? Oh, this is just a percentage thing. They're just like, hey, can you recognize that if you take 55% of something, you're losing 45%, right? Because that's, not 0.45, 45%. You're losing, because again, it's in decimal format. So you keep 55, you lose 45. That's what they're asking. Boom, done. Next, 5. Victor decides to try 3 different routes of a period of 40 days. Table above, you track whether you arrive to work later on time, particularly according to what's the probability, we just went over this, if Victor will be late if he used route A. Goodbye, goodbye. We're only limited down to route A now. What is the probability that he will be late? He's late 6 out of a total of 11 times. That's it. So watch that language. Next, number 6. In a poll of 14,000, blah, 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 95 per day is compared with 91 per day. If a poll of 14,000, 95 per day, that's 2 years ago. The results had a margin of error of $4 at 95% confidence level. Which of the following is a reasonable claim to make based on this sample? Okay, let me think. Hold on, let me just read this again. We're at 91 per day 2 years ago. So margin of error. 1 second, 95. So margin of error of 91 and 99. Okay. Not all adults. The language is too much. But every time I see every time I see margin of error, I go, hey, it's that much down plus that much up. Nope. That's a misuse of the confidence level, excuse me. Maybe C is right because you can see it's down. It can go down to 91. So that is possible. No, this one doesn't make any sense. Well, they switched the dollar amount to percentages. So that's weird. All right. So it's got to be that one. Which of the following is equivalent to the expression above? So this is just, finding like terms. So 14 minus 70 is negative 56. Q squared. Yeah, I'm not using a calculator. You can if you want. 8pq and 40pq is 48pq. And then 9p squared and negative 9p squared, is plus 8p squared, right? So, they didn't, but then, then they factored out 8, it looks like, and they put the p squared. It's probably this one, but let me just double check. So then you put the p, they divided everything by 8. No, it's not this one because it shouldn't be 48. Okay, so let me just keep, it's probably this one then. 8p squared plus 6pq minus 7q squared. Yeah, and it's got to be c. But then they factored this. This is such a weird one, but it's pp multiply 7, so it's 7, positive 7, and negative 1. But it's q because it's q squared. This is more difficult than what you'll get on the SAT. Don't worry about this one. The combining like terms, that's normal, but then all that factoring is like, it won't be that hard. Don't worry. Compare this. Okay, then what is the value of b minus a? I'm just trying to think what the best way, because again, these systems that they give on these are just way too hard for what they give on the SAT, but I have to do it, so it just kind of annoys me. So anyways, we'll distribute. We've got 3a plus 3b, and then we combine like terms. I'll move it over. I'm trying to do it in my head. So it becomes negative 1.5a, right, because we minus 3a from both sides, and then becomes minus 7.5b, right, because we subtract 3b from both sides equals 0. This one, again, just in the interest of time, I'm trying not to make this go too long, so I'm doing some of this in my head, but it's 5b minus 5a, and then, so I'll say negative 5a plus 2.5a is negative 2.5a. I'm putting everything on the right side, and then so I'm combined those, and those are that. Then I got the 5b, and then I'll subtract 5.5b from both sides, so that's 5b minus 5.5b is negative 0.5b, and then everything is equaling to 0. So I know I put it on the right side, but I kind of flipped it here. Doing a lot. Again, I'm really just solving this to solve it. You don't have to worry about this problem. Now we're trying to find b minus a, and there's no shortcut really here, right? Because if I multiply this by 15. Yeah, so I'm just going to solve for a and solve for b. So I'm going to multiply let's see, what's the easiest? If I multiply, so 15, 25. See, these numbers are so bad. I'm going to multiply the bottom by negative 15, okay? Because that's just the thing. I don't know. It's just what I'm thinking of. So 2.5 times 15. I could probably do this in my head, but it's all right. That becomes 37.5. So 37.5a plus 7.5b equals 0. So then we add these together, and we get 36a. Oh, wait a minute. A equals 0. Because we're not going to have anything on that side anyways. 36a equals 0. So a equals 0. B equals 0. Okay, I don't know if I did this right. Wait, 0, 0, 0. I mean, it works if they're both 0. Okay, I'm just going to roll with it. It's such a weird problem. Okay, 2 left. 9, a function, w blah, blah, blah. Constants a is 3. So we know that 3x squared plus bx plus c. And we know that when we plug in 3 and 15, we get 0. So those are the two zeros. What is the absolute value of b? Hold on, oh, I know how we can do this. So check this out. We've got x-intercepts at 3 and 15. Remember I told you the vertex is in the middle of those. So the middle of those is 9, right? The average of 3 and 15 is 9. And so that means negative b over 2a, which is 6, has to equal that vertex value of 9. So b equals negative 18. Normally on free response, you never have a negative, but I think that's right. I have seen that mistake on Khan Academy where they have a negative when you shouldn't. But anyways, maybe I made a mistake. We'll check it at the end. Last one, little trig. So we got sine 58 equals that, whatever. To the nearest tenth, what is tangent of x? Got it. Okay, let's see here. So it's opposite over adjacent, but we don't know that adjacent. Okay, so let's find this side first. So so we'll use tangent. So tangent of 58 equals opposite over adjacent, which we'll call that x. So it's basically 12.4 divided by tangent. Make sure we're in degrees. Tangent of 58, right? I know they gave us that value on the right, but I'm just going to do it here. So this value x is 7.75 approximately. So 20.15 minus that answer is 12.4. So this side here, oh, look at that, it's 45. So then tangent, what do they want? Tangent of x, right? Opposite over adjacent, it's 1. So I think that's right? Cool. And that's it. Let's see if we got them all correct. I don't know. Let's see. No, I got one of them wrong. Dang. Okay, so it was 54. Okay, so let me see how I did that wrong. 1 second. Oh, wait. Yeah, that's so weird. So the middle of this 3 and 15 is 9. So that's where the vertex is. And negative, cuz it's so weird. Negative b over 2a. 2 times 3 is 6. Negative b over 2a equals 9. I totally messed that up. How did I get 18? I did it's 54, but I think it's negative 54 because it's negative b, and then you have to negate it. Let me see why they say it's positive 54. It definitely is 54. I did my multiplication wrong, but isn't it? It's minus 18. It's negative 54. Oh, they want the absolute value. Oh my God, I totally didn't read that right. Okay, so I apologize to Khan Academy. That was not their fault. That was my fault. I misread it in terms of saying like they made a mistake and allowing you to put a negative. They actually said absolute value. So I made that mistake. Yeah, you can definitely rewatch this stream. It's going to be posted as soon as we wrap up. We're about to wrap up. Okay, guys, I'm so sorry. I have a really, really busy day and I got to bounce. I want to answer more questions. And this is amazing. So many people came. I really appreciate it. Thank you guys so much. If you did like the video, please, please, please drop me a like. It's such a huge help to the channel. Makes a really big difference. So, and feel free to leave a comment as well if you have any additional questions. I'm going to do my best later in the day to try and respond to as many as possible. I know you guys are stressed and have the test tomorrow. But it's just a lot of things going on here as well. So please bear with me. But again, thank you so much. Check out our Discord server. Honestly, it's amazing. It's totally free. Everybody on there is a legend. You can just go and work with people and study with people. So it's really, really great. If you want, check out our video course, as I already mentioned. It's in the description link below if you want to check it out. Only $15. And that's it. If you want tutoring as well, hit us up, tutoring@scalarlearning.com. We got a team of amazing tutors, all sorts of different price ranges. But they're the best of the best, and that's it. So, hey, you're very welcome. Yeah, it does say absolute value, Alexandrina. I missed that. So that's my bad. That's on me. Okay, anyways, guys, thank you so much for joining. As per usual, good luck tomorrow, and I'll see you in the next video. Take it easy.